Yeah? What? I don't understand what you're saying. Okay, I don't quite understand what you're saying. Oh, yeah, why? I went through, Oh, you're asking me whether your answer is correct? I don't know lah. You ask me to check. You don't answer key, man? Then you got tell him my answer or not? Like I mean, huh? Explained it 2024? 2024. Eh? How come like I don't have I got that day someone sent it to me the 2024 one. Was it Nathan? I think Nathan sent me, but then why didn't I keep it Yeah, why didn't I Yeah. I won't ask you. Ask myself. Throw away your things already Oh, this 20 oh 2023. Oh no, it's all here. Sorry. I have it here now. Yeah, I thought I didn't have it. Ta-da! Final year exam. Hey shit this the whole works I'm so this like this math also here no. Wait Huh? So yeah lah. Shit lah, Ben. You are damn unprepared no for your exams. You're like half prepared. Now you realize got one year for full set paper here. Is it? Anyway, it's inside the folder now. Okay, in case Alyssa wants to open it up. Right, so for the rest of you, I'll just open up this one here. The rest of you all La La Land already. Tomorrow last paper. Last paper lah. Then afterwards can enjoy for like 6 months already. October, November, December, Jan, Feb, March. Oh yeah, you start early March. Yeah, correct. You start early March. So 5 months. Huh? Not a lot. Go and get your internship done. No, legit, go and get your internship done. Go and get one internship, job shadow or something like that. Go and find someone, go and find your parents' friend or something like that. Just apply for like a month and go. Right? During November, go. During then afterwards go family holiday or something like that. Or January go. Right? January should be easier to get internships because most people start work, but then not a lot of students available to help. Yeah. Yeah, I'm telling you lah. Right? Because the game now is no longer just degree. The game now is experience. So you go for internship, you get your experience and you can put it in a resume. Right? Make sure the guy like formally writes it for you, writes a letter or recommendation for you. You can put it on your LinkedIn profile. I'm sorry, you're 16, you have to start already. Okay? Right? Those I mean Isaac and Alyssa also listening in also, yeah. Right? I know it sounds ridiculous, but time to get your time to get your internships done. Time to get your resume. Start building up your resume. You all got the CCA settled already. At least the two of you, your CCA is more or less settled. CCA grades, then plus internships, right? You're unbeatable. You know what I'm saying? Yeah. Start with some medical profession. If your family friend has a doctor friend or anything like that, just job shadow, stay in a clinic 2 weeks. Also can. Right? Whatever you do now will help you for your uni application. Right? Then when you do it in your uni, will help you for your job application. Yeah, I don't know lah. Like go and do something. I don't know. But clerical work a bit sian lah. So yeah, your aim now is to do job shadow, not to actually do anything, because I don't think anyone would trust a 16-year-old to do any actual work, right? Your job is to show that you're interested in learning. Yeah. Okay. So you have to get that done, right? No thanks. Don't. Yeah, don't. Yeah, all the you shadow me, right? Most of the time I'm just doing stupid shit like this. I show you what was I doing. Okay. Someone asked me a question, then I go to my YouTube studio. I go and look for the part where I was explaining the question, and then I I share the video. I put a timestamp. That's most of my job. So I don't repeat myself. So I just send them. This is where you need to pay attention to. Okay, good. All right, my job is done. So most of my time is spent doing this. Doing this kind of stupid shit. Like me trying to figure out where the where the parts I've done before are at. It's damn dumb though, but it's quite funny. So what do you want to ask? Eh, God, I don't see any. I mean, don't have one. Did he send me the wrong file? Cannot be right. Oh, there we go. Okay. No, the file is so big that. Okay, MCQ. Come. What questions you want me to go through? You got the file? Open the file. If no questions, then I'll have to force you all to do speed run now. Because otherwise, you are here, right? Let's make it worth your time coming down, right? Then we can just do this speed run. Isaac, any questions from this? 22. Huh? Oh, you're taking a paper. You're checking, huh? Okay. Isaac, questions you just add in here. Alyssa, right? I will suggest you try to open the file. In the shared drive, the file name is this. I don't know what is this. REPIP. Yeah. Yeah. Then what? What you want me to go through? I don't make me bored, eh? Two of you. 1339. I got 1339. 13. Or is it that you all done before already? You did this before already. Then no other questions. You also done before already, Elisha. Okay. Then which ones have you not done yet, the two of you? 24 done. 23 done. Oh, all done. 22, 23, 22, 21, all done. How about my papers? The Chongqing High Crescent Girls, all done. Kevin finished Catholic and Chongqing. Please go and do that. Maybe we do a speed run for Chongqing later. Chongqing done already? Chongqing done also. You? Chongqing also done. That means you haven't yet. Okay, then Crescent Girls? Crescent Girls? Crescent Girls done also. Okay, oh my god. You guys are closet killers, man, I tell you. Yeah, closet muggers, you know. Huh? Like quiet, y'all don't like don't tell me, don't ask me anything. Then how? No, like only bits and pieces only. Okay lah, let's go bits and pieces. 13. I got request for 13, is it? 13 Okay. Yeah. So straight away they inform you that the atmospheric pressure is 760, right? Which means that you expect this level, you expect it, right? This arrowheads here, right? These two arrowheads, you expect it to be 760, but it's not. It's less than 760, right? It's 730. Straight away, that just means that the trapped air inside here, right, has a pressure of 30 mm mercury. That's all. Is that okay? Yeah. Right. So this one here is don't get tricked by the other numbers. What now? The 25 mm high lah, the 40 mm, the the 10 mm, all these all fluff one, all useless, right? So you just be very clear. This level supposed to be atmospheric pressure, but atmospheric pressure is 760. This one shows you 730. That means that you are missing 30 mm mercury. So that means the trapped air inside is pushing the level down by 30 mm of mercury. Now hang on. One more thing. Could it be possible? Let's say I ask you hypothetically, could it be possible that the atmospheric pressure is 760, but then the mercury column is 770? That means this column here, right? Could it be 770? No way. No, not possible at all. Okay, there is no possibility that it can be 770. You get what I'm saying, right? If you tell me that, oh, what if there's a like, you know, maybe there's a hole, right? And you know, so the mercury level is rising. If there was a hole, this mercury level would have risen all the way up already. Or sorry, not risen all the way up. This mercury level will drop all the way down to the same basin level, right? Because air will go in and then push everything down. So ain't no way that this level is higher than the atmospheric pressure. If this is the case, if let's say for example, they tell you the atmospheric pressure is 760 mm mercury, and the height here is 770, right? That's them telling you that the atmospheric pressure that they reported to you is wrong, because this will be the truth, right? The highest possible height on an ideal barometer is the atmospheric pressure. It cannot be that your this reported pressure. That means this reported pressure is wrong. You know what I'm saying? Like, I mean, if they try to be funny, right? They give you A, B, C, D, right? Option D, the atmospheric pressure quoted was wrong. That's the answer. Can? Okay, that's 13. The next request is 39. 39. So go all the way to 39. 39. Actually, if you know there's not many questions, then you all don't need to come down already. Unless I choose a paper and then we do. Okay? Right. What statement about production of electricity in a nuclear power station is correct? Okay. Production of... Oi. Oh, yeah. Sorry. Your year 4, this is a new syllabus. Sorry, I was wondering, hey, how come this is in syllabus? This is in syllabus, right? This is in my notes. In the nuclear notes, at the last 2 pages, there's fusion versus fission. That's right. Okay, so carbon dioxide, no, it's not, right? Nuclear power stations do not produce carbon dioxide. In fact, what do they produce? What kind of emissions do they produce? Well, technically, they don't. It's not really emissions, So you can say that it's just water vapor, right? But yeah, it's nothing. Yeah, you don't have anything else. Okay. It looks like D is correct. It looks like D is correct. You know. Yeah, it looks like D is correct. Let's look at B. C is wrong already. Okay, because it's not protons, it's neutrons. Yeah. So we use neutrons to collide to the uranium-235, right? Collide with uranium-235, and then we cause fission. This fission will cause 3 other neutrons to come out. Okay? Did I go through this before? Did I mention this before? 1 neutron collide with uranium-235. Uranium-235 will fissure. When it fissures, it produces 2 fragments, right? You don't have to care what the fragments, but on top of the 2 fragments, it produces, right, big atoms here, big atom here, right? I mean, smaller than uranium-235, right? There's 3 extra neutrons that comes out. The thing is, what happens if you don't control this reaction? What happens? These 3 neutrons, correct, will continue to go through another fission, 3 each, right? 3 fissions each, and then you will have 9 neutrons. Then 9, you go through another 9 fissions, and you get 27 neutrons. So if you continue to let it go, right, it's basically a nuclear bomb. So in nuclear reactors, what do they actually do? They absorb 2 out of 3. They go by statistics. So by statistics, they absorb about 2 out of 3. Okay. So these 2, right, will be absorbed away. That means you're only left with 1 to continue fissuring. Right? This is called a controlled chain reaction, right? Or a self-sustained controlled chain reaction, so that this neutron will continue to do fission, but at a controlled rate, so that it can continue to produce energy without going kaboom. Hadawa? Once it reaches a certain number? No, man, it's very hard to stop. You know, it's no way like, you know, oh, I time you, 1,000. No such thing. All these things are all ongoing process, man. Yeah, these are all ongoing process. I mean, nuclear power plants and all power plants run 24/7. You want your lights at any time, it's always on, right? Because the power plant is running. Yeah. Okay, so D is the best answer. D is the best answer, okay, because it is exactly what we talked about, right? Boil water, produce steam, steam turn turbine, generate electricity, right? So there you go. But where's the production of thermal energy? The production of thermal energy is from this fission itself. The act of this fission, right? The boom like this, right? The fission like this, right? This is the release of thermal energy. Now, crudely speaking, it is like that, right? Once you get into JC or IB, right, you will learn this in a more refined manner, all right? So this is the heat, right? So your particles, these particles fissure, it releases energy. The energy is used to boil water, all right? So it's a boiler. Okay, how is this different from, let's say, for example, hydroelectric dam or a wind turbine? How is this process different from that? Hydroelectric dam or wind turbine? So for hydroelectric dam, wind turbine, right? We don't need to boil water, right? Hydroelectric dam, the water will turn the turbine itself, right? The water flowing, right? You store all the water in the dam at the back, then the dam will flow down like this, and then you will generate electricity. Okay? Wind turbine, same thing, right? Wind blow, right? The wind blades turn, and then it will generate electricity as well, right? You don't have to boil water for those things. How about solar power? What's up with solar power? So solar power is like this calculator here, right? You have the solar cell here. Huh? Came out, paper 2? Solar cell? Oh, that one is just hot water only, that one. That one no electricity, that one. That means just black pipes with water. Explain why is it black, explain why is it made of metal, right? That sort of thing, right? This kind of question all standard one, bro. Like after a while, right? If I started early with you enough, right, I would have made you gone through the whole list of things, really. No, it's only a matter how much you can cram in, right, every year. Anyway, okay. So this one here, this solar cell, this one converts solar energy into DC electricity. So solar cell creates DC. So that's why it's called a solar cell. A cell is what? A cell is a battery, right? So solar cells means they convert sunlight, solar energy into electricity, DC. Okay. So anyway, but here's the thing. Look at B. During the nuclear process in the reactor, only a small amount of energy is transferred to internal store the surroundings. What B means is that only a bit of heat is lost to surroundings. Okay, right? That's a bit of a concern because, like, you know, how are you supposed to gauge whether not it's a bit or is it a lot? Like they never really mentioned, right? But the fact of the matter is a lot lah, all right? There's a lot of but as to why it's a lot, actually you don't know this yet, right? You will know this next year when you do thermodynamics, right? In IB, thermodynamics, there's this thing called a heat engine, right? There is a process whereby we need to lose a lot of energy to the surroundings for the entire process to continue going, right? So B, right, is wrong because it's not a little bit, not a small amount, it's actually quite a lot, right? But for D, right, D is definitely correct, right? Because this statement here is like the true and always, right? I've always also gone through this myself, right, in class, right? I've shown you how the electricity is generated. Okay, so 1339 done. Any other questions? Elisa, got any questions? No, don't have. Nathan, any questions? You just joined? No, okay. All right, don't have. I will now give it to you guys. Let's see. Let's see. You all never do MGS IP, right? Wait, Advaita gave me MGS IP. I don't. Oh. Hang on. Advaita gave me the MGS IP 2020. 2025. Yes, that's right. And no, she sent it to me in picture form. So like that. It was like this. It's all inside the shared drive. No, not the shared drive. It's all inside the WhatsApp. Huh? Got her working Then how you want me clean it up? Well, if I clean it up now, it'll take a long time Huh? Wait. Let me ask her whether she has a clean copy. Wait, let me ask her first. She already got her marks already, no? No, as in like she got her final year exam score already. Yeah, she got it already. Yeah. Which one? Which question? Okay. All right. Calling once, calling twice. If don't have, what I'll do is I will give you her 2022. Her 2020. You all did this before. Okay, you all did this before, right? 2022. Why is it like that? Oh, okay, this one. This is 2023. 2023. Let me see whether this one legit or not. Like whether more challenging enough for you or not. Actually, like not really. It's like very lame, man. This one. No kick leh. Oh, but got nuclear lah, which is important lah because. But like no kick You can do this in 15 minutes, I think. Some more only 25 questions only. 30 questions only. Che. Huh? Don't know also. Special. Should I go and dig out another year 4 one? Hang on. Walao, this year you all do papers like drinking water like that. I thought I already prepared a lot of papers for you already. You all are really just gasak everything. Huh? Don't give me the wet in doubt one, I tell you. I swear to you, I remember who that guy is. Some of the guys swimmer some more. Wow, Punggol Secondary. Cannot lah. Cannot. Okay. You all give me 5 minutes, okay? You all give me 5 minutes. Let me see whether I can work my magic. Hang on. No lah, not that lah. Oh, but if you want to do that one, can lah. Because that one is damn fun because that one is in picture form, not PDF, you see. She don't have. She got 84%, She got 84%, You all better back up, Yeah. You all better back up, After a while, it's only a matter of whether you remember what I taught you. Because, it's not that tough one. You wait. I will find it for you first. This is... Hey, how about this? Nanyang girls lah. Huh? Got do meh? Don't have lah. Nanyang girls never do lah. I'm pretty sure don't have. Wait. It's IP. Why? Express no challenging enough for you Huh? Never say that. Please, you mean it, right? Hey, what the pong? Nanyang girls don't take test nuclear. For what, sia? Waste time lah. Huh? Nanyang girls go on to Hwa Chong mah. Correct, right? Yeah. We are SCGS. Hey, Alisa, SCGS 2023 you got do or not? SCGS. Huh? You never do? Oi. SCGS IP paper. Huh? What? Why? Yeah lah, they IP they go straight to A level. But if they express then they can choose Huh? Yeah lah. Wait let me this one. Alisa, this one. SCGS 2023. Got do or not? Got do before or not? Don't have Never do before. Okay lah, don't have then that means can maybe can try. But hang on, let me just work my magic first. How about 24? 2024. Alyssa, you did it before. Yeah. Wait, you quiet first. Let me go and download this thing first. Wait, but then 2023 don't know whether got the 2023 don't have nuclear. But Alyssa already do 2024. I'm wasting my time, guys. I shouldn't take SCGS. Unless you all want. And then Nanyang Girls is useless. Oh gosh. Okay, sorry guys. St. Andrews Huh? St. Andrews, you do before? Oh, don't waste time did we do Cochon already? We did Cochon, right? Okay. Okay, we got it. CHIJ Toa Payoh. Right, there we go. This one here. Can? Yeah. No, we never do this, and some of this is 2025. Yeah, but O level Okay, I print for the three dudes here first. Printing. For those who are online, hang on, let me just pull this out for you. CHIJ paper 1 2025. Yeah, okay. I'm gonna put it onto the shared drive. Speedrun. CHIJ paper 1 21. Answer is with me here. Yeah, answer is with me here. Whoop. No, you didn't see anything. I opened the wrong one. Okay, so I just uploaded this if you all go to 2025 I mean I'll rename it, sorry, I should rename it as 2025 CHIJ 20 paper 1 25 CHIJ. Okay, No, because I was just looking at some of the questions and I think they're quite interesting. Yeah. They're quite interesting. I would dare say they're like maybe IP standard. Yeah, just scanning through the thing, this is a bit more challenging. The MGS one was so easy. Come on, man. Lame. Okay, let's see how fast we can finish this. You got about an hour. Oh, actually, you have an hour, right? You have to finish this in 45 minutes. Right, let's go. Speed run. Right, tomorrow is your exam paper. Hang on, Wait, I need to close some of my shit first. Okay, when you're ready, on your mark. No lah. Okay, let's those online. Are you you got the file? I mean this file, this one here, the one with I just loaded on the shared drive. Not bad. Actually, the first question they give you a bit of assistance. Yeah, they give you a bit of assistance. They want you to do prefixes. Yeah, but you're supposed to memorize at least this one. You're supposed to memorize this. The width of human hair. You're supposed to memorize this. Like, just take note for tomorrow's first question. Probably they ask you what's the height of man, what's the width of human hair. Yeah, height of man is what? You say easy what? 10 to the power of what? 1 to the 10 to the power of what? It's always to the power of something. Orders of magnitude. Height of man is what? Height of man. 10 to the power of 1 Huh? What depends on the unit meter. Yeah, so what's the order of the height of man? You're not gonna like this. 2 you're 100 meters tall Brother. Cannot be minus, bro. Minus, that means you're like 10 cm tall, no? It's 0. So order of magnitude, the power, right, is always integer value. Okay, and it's always 10 to the power something. Okay? 10 to the power 0. Right? Humans are closer to 1 meter than they are to 10 meters or to 10 cm. Therefore, the order of magnitude is within the 1 meter plus or minus range. Okay? Right, so this will be the order of magnitude for height of man. What's the mass of a car? What's the order of magnitude for mass of car? Right, mass of car. Mass of car. 10 to the power of what kg? 10 to the power 10. 3 lah, yeah, correct. Okay, good. Right, 1,000 kilograms. Right, around there. Okay, small car lah nowadays, right? Last time used to be the usual size. Nowadays, all your SUVs and all that. All your Alphas. All your Novas. Right not? Huh? Or worse, maybe I'm quoting the lower end of it. Maybe all G-Wagons. Alright, or maybe BMW X3s. Huh? Okay. I don't know, man. What's your best answer for this? Looks like this is quite right. This is a bit too thin, man. This is smaller than a micrometer. No hell, wispy hair. Right, then you need to figure out this distance times 10 to the power. Yeah, it can't be giga. Giga is what? Giga is times 10 to the power of 9. No, not minus. That's 10 to the power 9, right? So you got your kilo, mega, then giga, right? Right, kilo, mega, then giga. So 9, right? If it's 10 to the power 9 and then you minus 1, that's 10 to the power 8. So it can't be that because that's 10 to the power 11. So it has to be trillion, right? Tera. Okay, so A is your answer for this. Okay, good. Next one. Good luck to you. What's the unit of pressure in base units? Woo. Oh, what's base units? Good luck to you. I swear tomorrow's gonna come out. What's the base units of volts? You're done. So base units of electricity terms is the hardest. Yeah. Like base units of volts is really hard. Okay. Anticipating your paper 1 is gonna be hard. You understand? Because your paper 2 was manageable. So I'm going to guess your paper 1 is going to be one of those like slap you in the face type. Right? So here's the thing. Your first 10 questions will be those kind of like, you know, you wake up kind of question, right? So what you want to do is you glance through the first 10 questions, you realize those are impossible to do, right? Then you go and make sure you spend more time on the rest of the questions first, then you come back to the first 10. Okay? Time management. We do this first, then I do a side quest. What's the base units of volts? But in the first place, right? What's base units, bro? The heck? You forgot. Last week, the exam paper 2, now you forget. Come on, list me the whole base, whole bunch of base units. kg, meter, seconds, thanks. Kelvin, what? Ampere, no, not coulomb. Coulomb, not your base unit. Coulomb's not. Candela is our syllabus, but it's part of it, but we're not going to write it down. The last one is mole. Yeah. Kamol, okay? Kamol, all right? So just remember, maybe you can form a mnemonic from this. I don't know, I don't care, right? But yeah, there you go, your 6 base unit. So you're supposed to express pressure in terms of base units. So you got to think about an equation for pressure. Say what? Pressure is force over area, very good. All right, so what is force? What's the units of force? It's supposed to be newtons, right? But newtons is not part of it, so you need to break down the equation down into another form. So F equals what? F equals to ma over A, like this, right? Which is area. Don't mix this up. This is this area, and then therefore the units are kg ms minus 2 divided by m squared. You understand that? Right? That's what you're supposed to do. Right? I know it's for 1 mark, but no choice. Right? And you have to do it fast also. You need to know how to do it, and you need to do it fast. Hey, Alisa, tomorrow is what? Paper 1 and 2, or just paper 1? Oh, wow. Okay. Then you got any paper 2 question? No? Don't have also. Oh, okay. So if you want to ask anything later on, please understand that I am tied up until around 7 p.m. tonight. So if anything, you just drop it into the tele chat, can? Thank you. Okay. What? So what does this work out to? What? A lah. Right? A is the answer. Okay? A is the answer. Alright, side quest. Side quest, take out a blank piece of paper or flip to the back. Okay, we're gonna do a side question now. I want the base units of volts. Right? Base units of volts. Right, base units of volts. Oh, this is hard. So you got to think about an equation. Huh? V is equals IR, you go down the wrong path. The classic one, because R is ohms, and ohms is another unit on its own. So it's another problem on its own. Think of another equation. So P equals to VI, not bad, still can. You can do P equals to VI, so V equals to what? He's I know already. Sec 2, he must have played them a lot, right? The math all jialat one, no? Cannot do fractions, Pi your head lah. P over I lah. You said P over I lah, they. Right, P over I. Okay, still not so bad, right? P over I. You can use this. Huh? Energy over Q lah, yeah. Okay. Right, but hang on. We can do both, right? So let's work on this one first. So power. What's the units of power? Yes. What's the units of power? Yes lah. Okay, so joules per second. So power is what? Energy over time over current, which is I, right? Like this. And now you have to express it in units, okay? Now, but if you express it in units, this is joules per second, right? Over ampere, right? Over ampere. Huh? Ampere, current ampere. Okay, but joules is not a base unit, so you need to work out what is joules then. Joules is what? Joules is energy. Energy is what? Work done. Work done, what's the equation? Force times distance, right? Newton meter. So it's Newton meter, S minus 1 over ampere. These are units. This is not area. This is units. This is ampere, right? These base units. So the N is still not base. So what's the N? MA, so kg, ms minus 2, ms minus 1 over A. That's your base units. Everything in, simplify it. That's your answer for this. Yes, right? So if they want to play punk with you, this is what they can do, right? I'll tell you this, okay? Finding the base units of resistance is worse. Finding the base units of resistance is even worse because R equals to V over I. Right? R equals to V over I, which means that you're going to find the base units of V first, whatever here, and then you divide it by another amperes. Then I mean, you've already found this, then it looks easy, right? But the problem is a lot of students will get stuck not knowing what to do next, right? So you find the base units of V, plug it into this one here, divide it by amperes one more time, that's the base units of resistance. At this point, guess, hey, learn to love the process lah. Right? You only want the end point, meh? Training is hard, yeah lah. Right or not? Discipline your head lah, discipline. Right? Life so difficult, discipline. You hear that rant before? It's quite funny, the guy. No, there's this TikTok guy who was ranting. It's like, discipline. Every day wake up so early in the morning, discipline. Your head lah, discipline. You think I like this, meh? Huh? Ben Wo. No, no, Ben Wo is damn extreme lah, Ben Wo. Well, he shout his way into F1 pit. He cursed. Yeah, he really cursed and swear until into the F1 pit. Walao, this fella. Ben Wo, damn funny. Hey, yeah, oh, okay, yeah, you do this. Answer. Don't take too long. What's the answer? Oh, this one? Huh? D lah, your head lah. Hey. Like that you lose marks for nothing. Careless. Hey, you got the don't check all the options syndrome, right? You are the type, see the first option, okay lah, this one makes more sense than A. All your OAS is all A and B one, no. Check first answer, looks legit, put A. Don't look legit, if in doubt, put B. Then all your OAS is all freaking A and B only. A. Period is the back and forth motion. 30 seconds divided by 20 is 1 period. That's 1.5 seconds. Right? Going from X to Y is half a period. So 1.5, 0.75. Don't waste time lah. This kind of like 5-second question, then you waste your marks for what? Be meticulous. Check your work. Okay, number 4 is challenging. Oh, number 4 is challenging for sure. Wait, for those who are online, I got a timer for you. Okay, 1 minute is up. What's the answer? You got D. Anyone else? You use equation. You use graph. Okay. That's why when I was scanning through, the moment I saw this question, I was like thinking, wow, this school at least not so bad. This school at least a bit more challenging. CSI got IP or not? IP to where? Oh, IP to C. Do they IP to CJC? CHIJ ma? Can't high, right? No man. Catholic school, right? No man. Okay, come. Let me show you 2 ways of solving this using graph method. I try not to use the equation method, because the equation method, if you don't understand fully how to use it, also a bit no point, right? Actually, yeah lah, really quite difficult to use the equation method, because you have to use 2 sets of equations, but I can show it to you. Just that using the graph method might be a bit easier here. Okay, when you throw the ball upwards, right, there's an initial speed u. So your graph shouldn't start from 0. Okay? But that's another graph, right? You can draw the graph starting from 0 if you knew, but if you don't know, you shouldn't start from 0. You should start like that. This is how the ball's velocity time graph will look like. Huh? You shouldn't be drawing ST graph. If you're drawing a VT graph, and you draw ST graph, it's not going to be a straight line. ST graph will be a curve. The speed is increasing, the gradient is increasing. Okay? So you shoot the ball upwards like this, right? There'll be a point in time it reaches 0 here, right? The speed is 0, which is here, right? That's the 0 mark there, right? The speed is 0 there, okay? But that turns out to be 5 seconds, right? Maximum height of 125, so this is 5 seconds, right? They did say that it reaches a maximum height, so this is your maximum height, all right? 125 meters, which means that this area here is 125, okay? Then the question will be, right? It lands here. Sorry. So it lands here. It doesn't come back down. So if it lands there, it will land somewhere. Like it says, 2 seconds later. Sorry, 7 seconds like this. So the rest of this graph here is actually not there, right? Because it landed already, right? It landed already. And sorry, this 5 seconds is a bit out of proportion. Hang on. Let me just draw this a bit nicer, a bit. So 7 will be around here. Yeah, okay, wow. So they ask you what's the height of the cliff? What's the height of the cliff? So what you might need to do is you need to take this area, 125, minus away this area, right, which is the falling down area, to get you the height of the cliff. You understand what I'm saying? Yeah? Okay, so that's the proper way of doing it. Okay, but you definitely will need to know what's the speed here. How much speed is there? Anyone? What's the speed? Right? It reaches maximum height at 5 seconds, and it falls for 2 more seconds. So what's the speed when it hits the top of the cliff? Like what's the final speed here? 20. Yeah lah, trying to figure out whether or not you understand or not. Why is it 20? He understands. I think he understands only. Then the concern is whether you understand or not. Because you're looking at different parts of the entire thing. So got very bad ADHD. Cannot focus. Like looking everywhere. Hey. I point here. Then you look there. I point here. Then you look here. Gravitation acceleration. He said the gradient of the graph is 10. Don't need lah, bro. So at some point, right, you have to intuitively know already, objects falling, right, due to gravity, right, every second gains 10 meter per second. Not every second travel 10 meter, right? So if you from 5 to 7, from 5 second mark drop down to here 2 seconds, what's the final speed just before hit? 20 lah. Okay, can? All right. So what's the height of the cliff? 125 minus this small area here. That's the height of the cliff. Cannot. Can, right? Okay, good. All right. Now, those who want to use the equation, how do you use the equation? Let me show you how to use the equation. You won't like it, but I'll show you how to use the equation, okay? All right. First and foremost, right, can you find u or not? From this picture here, what's u? 25? Because it's half times 25 times, no, like, cannot be. Half times u times 5 is equal to 125. Half times u times 5 equals to 125. Apa? 50 ah? Wow, this fella strong. Okay, so u is equal to 50 meters per second. That's like the initial speed, right? 50 meters per second. Right, so you toss the ball upwards with initial speed of 50 meters per second. Okay, so if you want to find the using the Suvet equations, all right, for those who learn Suvet and want to use Suvet, all right, the height of the cliff is basically, okay, ignoring the height of this man, right, the height of the cliff is this one here, right? Okay, so where's the starting position of the ball? Here. Where's the final position of the ball? Whoop, up, down, right? That's the final position of the ball. You understand? Okay, so initial position, final position here, right? The displacement of the ball, the overall displacement of the ball by the time it stops is up here, right? That's the overall displacement. So we use this equation, S equals to UT plus half AT squared, right? It's useful because it gives us 7 seconds, right? So we use S. S is the unknown because S is literally the final displacement from its original position, and that is exactly the height of the cliff. This equation is to be used even if you know that the ball goes up and down, right? Because S stands for displacement, not distance traveled, okay? This ball goes up and down. Obviously, the distance traveled is quite a lot, right? Right? The height of the cliff, the height above the cliff, and then the height above the cliff again, correct? But this equation, if you don't know how to use this equation properly, you get yourself in trouble. So you need to know that S stands for displacement and overall displacement, like what's the final position, right? So it's there. Okay, now equals to, now that we know that u is 50 times 7 plus half, then the problem is this, what's the a? The a is minus 10. Minus 10. Okay, why? Because we're taking upwards as positive, right? So a is pointing downwards, so that's taken as negative, and then 7 squared. Now, if you know how to use this, you will get this right. If you didn't know how to, you put half times 10 times 7 squared, you get this wrong. Okay. Can okay. Oi. You got 2 calculators because you abused one. Right? Do you get the same answer? Right? Or you could have taken the 125 minus away this small area, right? What's the answer, by the way? Is it D? Okay, it's D. All right, that's for number 4. Okay, let's go. We're supposed to do this fast one. Hey, yo. Okay, look at number 5, please. Answer for 5? Hmm? You got C? Yep, C is the correct answer. Yeah. Right. Any questions on this? No? Move on. 6? 6 is C also, is it? I have to punch the calculator in. Do ya? Okay, yeah. 6 is C as well. Moving on. 7. Oh, good luck to you. Well, these guys are really not playing. Lucky I chose this paper. But okay, like, it's workable. It's just that you have to work very fast. Oh, but technically speaking, for O levels, this question is not allowed. Technically speaking, this question is not allowed. Acceleration time graphs shouldn't be asked, but yeah. It's not a thing, so they're a bit more challenging, but yeah. Maybe they are trying to prepare their students. What's the answer for 7? C? Good. Yeah, C is correct. Right. Ben? What? You didn't get this one? Yeah. So you need. So acceleration time graph. Acceleration time graph. Area represents change in velocity. Negative area means you lose velocity. But really depends. So the idea here is that they say the initial velocity of 10, right? And the next graph in the picture you gave me negative acceleration, it shows me that it loses speed for a bit. So it lost 6. So you start off with 10 minus 6. But then in the next instant it becomes positive acceleration. So it's positive acceleration you gain, right? Which means that you look at the positive area, you gain velocity. Then down here you also gain, right? So 10 minus 6 plus 12, right? 3 times 4, 12, plus 4, 2 times 2, 4, right? Then total 20. Okay? Right, good. Next one. So that's why this question is not very legit because like you're not supposed to be given a acceleration time graph. Okay, come. Number 8. Mate, what's your answer? Hmm? Yes, D's answer. What's your answer? Number 8. D. D's your answer. Okay, anybody wants to ask a question on this? No? Move on. Right, next one. Number 9, answer ready? What? Yeah, this one you just need to do moments. Is D your answer? I believe everyone's answer should be D lah. Correct, okay? So number 9 done. Let's go to number 10. Number 10. Where should the position of the center of gravity be for the tractor to topple? You want it to topple? That's hella weird. Okay, you want it to topple? Then C lor, C's the answer. What kind of weird ass question is this? You generally don't want it to topple, right? But okay, right? This guy's a menace, right? So the idea here is the front wheel will be the pivot, center of gravity is in front, right? Weight points down, provides a clockwise moments, right? The tractor will. Oh, that's kind of weird. Okay, 10, 11. Alvin. You like this kind of question, huh? Is it what? Oh, there's trapped air. Okay, there's trapped air. So how much is the trapped air? 6. 6 here mercury. Okay. And then this one at the level here, 26. C is the answer. Okay, 11 here. So every one of their questions is a little bit one more step, right? So you have to kind of be careful. And I would expect IP kind of questions to be like this actually, right? So every time you do something, you gotta just double check. Make sure you don't. Yeah, you know, I would have put this at the front option. Like I would put 20 at cm mercury at A because then you have people like him, right? C first option only. Then they think that's the answer already. Confirm one. You know, actually, right? They shouldn't even put the air here like this. For what? Just leave it like that. You know, don't go and put air. You put air, you give the game away. Right or not? Right or not? Correct or not? You don't put air there, right? You like people will be like, what's that? They think it's vacuum. They say, 20 20, then they choose that. When I say people, it's Ben actually. Okay, so 11. About 12. I didn't bully you. Okay, don't anyone say things. Nowadays bully is such a sensitive word. No bully. Hey, what's the answer for this? C. I haven't checked it. Wow, can be quite tricky, guys. So they say that at first, right, my brain was thinking that they said the air is 190 kPa, right? I thought they were talking about this one here, but it's not. This is the trapped air. The trapped air is inside here like this. That's 190 kPa, and this one is 10 kPa, right? 10,000 kilopascals. So the total pressure here, same liquid, same level, same pressure, right? The air pressure there, right? Because they say air pump, right? Air pressure caused by air pump. So it can be quite misleading. I can see some students, right, mixing it up, making careless mistake, thinking that they're talking about the air here, then they go and try to find the air pressure there, right, which is wrong. Okay? So yeah, C is your answer. Right, the air pump here. Right, 190 plus 10, right? So then this one here. Okay, good. Right, 13. Oh, wow, these guys are really doing all the classic questions. Yeah, really legit. They're not holding back, you know. They're doing like their mindset is this. And if I'm gonna set a question, I might as well set the difficult ones. You got 13? Yeah, what's your answer for 13? Answer is D. M 5000 GH 40,000 watts. Yeah, okay, correct. Yeah. Yeah, so this answer. Okay, good. Anyway, this one is C. Yeah. Okay, number 14. This one here. Okay, yeah, this one here, all IP must do. That's right. This one's not supposed to be for O levels. I think the teacher forgot. What's the answer for this one? 14? C, right, C is the answer. They get further apart. Okay. Okay, pause. So this one I need to deep dive a bit. Why is the answer not D? Good. Right? Is that correct? Okay. If you say D, they move slower, means temperature has dropped. This is wrong. Okay? The temperature is constant. If the temperature is constant, means that the average speed of the particles is constant. Right? So average Ke, right, of particles, right, is constant. So it's not that they got slower or anything. It's just that now they have more space. So when you pull this piston away, right, when you pull the piston away, right, the particles inside, right, they have more space now. So therefore, they take longer to travel. They will collide with the walls less frequently, right? So which is why option A is wrong. Okay? So they will collide with the walls with the same amount of force as before because the Ke is still the same, but they'll collide less frequently because of the sheer like increase in volume. So the chance of them colliding with the walls is less. Okay? Obviously, B is one of those answers where if you dare to choose B, right? Okay, I will expel you from the school. Because your physics and chem gone case already, right? You're gonna tell me the particles expand, right? Nah, right? That's it, right? Expel you already, or maybe retain you for Sec 2. Okay. Yeah. Okay, then there's another thing. How about particles colliding with each other? interparticle collision. Yeah, that's chemistry. It got nothing to do with physics. Right? Particles colliding with each other has nothing to do with physics. Physics is all about the particles colliding with the walls. Okay, good. Right, 14 done. Let's go on 15. The first few questions difficult, then all easy already. But okay lah, not bad lah. Not bad lah. Okay, 15, what's your answer? Is he doing? He's passed 15 already. What's your answer for 15? B. Oh, you're caught up already. Okay, come. 16, tell me what's your answer. 16 C. These are solids. So this is solid, and then this one become liquid. So this is melting. So latent heat of fusion. Oh my god. Ben, you get the concept, but you're always missing something. Oi. Huh? Your cup is always 3/4 full. No. The swimming pool 3/4 full. No, right? Full, right? Okay. So this one here, there's a few things going on, but the fact is that this one is a solid, this one is also a solid. Okay? So this one's solid and this one's solid. Alright? And what's happening is that for the middle portion, those are the parts that is melting, right? It melts already, then becomes liquid. So this is liquid and this liquid. So for sure, you cannot be talking about latent heat of vaporization. This is off. Like the first thing you should cancel off is this one, option D. And you go and choose that one. Right? 不要粗心大意, be more meticulous, be more vigilant. Okay? Vigilance and meticulousness. Okay? Then you have to compare, lor. Right? You see, right? There's so many things that you can compare. You can compare the heat capacity of solid X to liquid X. You can compare the heat capacity of solid Y to liquid Y, or you could compare the specific capacity as a specific latent heat, right, of X during the melting process and to Y during its melting process. So it really depends on what you are comparing. Okay, let's look at option A. Solid X has larger specific capacity than solid Y. So if you ask me to compare solid X and solid Y, I'm looking at these two blue lines here, right? These two blue lines. And it is not larger because don't forget in this graph, the steeper the line, the smaller the specific gradient, right? It's a specific, So if the steep gradient, right, means the specific capacity is small, equals to small SH. Oh, that's you. I was like wondering where that Thai smell come from. That's you. Okay, small SHC, small specific capacity, right? Which means that it's very easy for the temperature to rise. That's why it's steep. Okay, small SHC means easy to rise in temperature. Okay, so A is out. Liquid X has smaller specific heat capacity than liquid Y. That means you have to check, right? Now then it's the reverse. It's actually not smaller. Look at the gradient, right? X is gentler than liquid Y. Liquid X is gentler than liquid Y. So this is a liquid here, and this liquid X and this liquid Y. All right, it's gentler. So in fact, B is also wrong because it's actually larger. So both A and B are wrong. Right, so C, right? C is the best answer, right? Because it is truly a shorter time taken for it to completely melt compared to substance Y. Okay, so solid Y, right? So if you compare the melting, right? The melting is here, right? This is the melting here, and that's the melting there, like this. Okay, so liquid Y takes longer to melt. Oh, sorry, solid Y takes longer to melt. Therefore, X is easier and has a smaller specific latent heat of fusion, right? This is for melting. Okay, Isaac? Okay, cool. 16 done. All right, let's look at 17. All right, what's the answer for 17? B, right? 17B? Eh, have you done 17, Ray? You put D? Wait, you want the least heat loss, right? So use aluminum because it takes longer, 10 seconds. Right? Yeah. So you will use aluminum and styrofoam because it takes longer. Eh? You chose styrofoam but you didn't choose aluminum. No lah, no lah. You just choose the metal that's also hard to conduct also lah. That means if you're a poor conductor, heat means that you don't lose so much heat, so quickly. Yeah. Right. So B is the answer. Right. B is the answer. Okay. So yeah, just take note of what do they want you to. What's the context? The context you want to reduce heat loss, so you want to let it conduct heat transfer. The slower the heat, the transfer heat, the slower the rate of transfer, the less heat you lose to surroundings. So that's 17. Let's go at 18 now. 18. Right, double-walled glass vessel to contain a hot liquid. Right, space. Right, glass walls, air outside, hot liquid inside. Which method reduces heat loss by radiate? Oh. Wow, this one here, this one is going to be one of those controversial questions. Right, so the answer is D. Okay, the answer is D. Because the question specifically says that you want to consider reducing heat loss by radiation, right? Radiation means you paint it white. White is a poor absorber, poor emitter of heat, right? Of thermal energy, right? If it's hot, then basically you want to be a poor emitter of thermal energy to surroundings. Okay, so that's D. Now A is legit what you want to do. You want to make the inner walls like a vacuum, right? Between is a vacuum. I'm quite sure you have this kind of glass at home as well, right? One of those Bodum glasses, this thing here, right, where you can it looks like there's two glass layers. Okay, right? So having a vacuum in the space between the glass walls will reduce heat loss via conduction and convection. Right? You reduce heat loss via convection and conduction. But the question did say that I want to reduce heat loss via radiation, so we chose D as answer. So 18 is D. Let's look at 19. Have you done 19 already? Have I caught up already? Or you guys are catching up still? Okay, 19. What's the answer for this? What? B, is it? Okay, wait, let me double check. Actually, I can check the answers, but okay, fine. Yeah, okay, B is answer. Okay, B is correct. You're okay with this? No questions asked. Let's go 20. 20 here. What's the shape between P and Q after half a period? So the current shape looks like this, right? A negative sine curve, right? The current shape looks like that. There's a negative sine curve. Half a period, what will happen? Half a period, positive sine curve. Okay, so 20 is C, Ben? 20 is C. Got it? Okay, good. 21. Ultrasound travels from air to water. What happens to frequency, wavelength, and speed? What's the answer for this? Very fast one. This kind of question is like 5-second question. This is an actual O-level question. Like your TYS, right? Some of your IP teachers also say, oh, go and practice the TYS. This one's the TYS. Frequency remains the same. Oh, sound travels faster in water. Speed increases. Okay, so B is answer. Okay. No, just yesterday I was doing this with the SOTA girls, right? And basically the idea here is this, right? Always remember that you have, let's say for example, a sound wave, right? A sound wave, right? Entering a glass block. Let's say a glass block like this. Then ask you how does the wave look like when it enters? But because sound travels faster in solids, it speeds up and therefore it bends like that. It bends away from the normal, yeah, like that. Okay. Then I even went through this part where the wave fronts, right here, to draw wave fronts. So I made them draw the wavefront, so the wavefronts look like this. Okay. Now this is especially so for ACSi, right? They like to play around with wavefronts because wavefronts is a very big thing in IB. Okay. So then once it goes in, the wavefronts become like that. They become further apart, right? Because the wave speed has increased. Okay. Wave speed has increased. But here's the thing, some students, they see this kind of picture, right? They blur, no? Huh? No, they think that the frequency is less. So some students, they see, right, like that, right? This picture shows me many waves. This picture shows me less waves, then they think frequency is less. That's wrong, Source. Depending on source. So that you don't change the source, the frequency is still the same. So frequency is unaffected. You got that? V equals F lambda, yeah? V equals F lambda, yeah. So speed is affected by the medium. So if you change medium, you change speed, right? But frequency doesn't change, right? So if let's say, for example, you go into glass, your speed increases, but frequency stays the same, the wavelength must increase. Therefore, your wavefronts are further apart. Okay? Good? Good. All right, just make sure you don't make the mistake there. 22, come, tell me what's 22. High pitch, low pitch, right? High pitch, low pitch. This is sound, right? This is sound, right? Okay, so high pitch, low pitch, loud or soft, sound speed always the same. C and D are out. Okay, so high pitch means high frequency, right? High frequency. If it's high frequency, means it has shorter wavelength. So B is your answer. Okay, so V equals to F lambda. High pitch means high frequency. Sound in air, I'm not changing the medium, so this is constant, right? And then therefore wavelength must decrease. They are really not playing around. they literally test this and then they test this together just to see whether they will get confused. Wow. I mean, really respect to the teacher who set this paper. I rarely see something like that. Yeah. Okay, 23 guys, come on. Where's the image? Oof. Where's the image? Right, image, right, is just basically the object reflected perpendicularly across. So C is your answer, right? This is your object, this is your image. Okay, good. 23 done. Next one, 24, come. 24, right? Light and lenses is for everyone, right? Yeah, that's right. Okay. Various focus images are produced on the screen by moving the lens and the screen backwards and forwards. Okay, right. Which statement is always correct? Whew. You see, this question is about you memorizing the lens diagrams. I said it many times already. D, the image is inverted. That is correct. Okay, tell me why. Tell me why ain't nothing but a heart. What? All real images are inverted. When is it that the converging lens, right? The only time you get an upright image, magnifying glass, which means that the image is where? The image is behind, right? Behind the object, like here, right? That means you have to put your eye here. For magnifying glass, you cannot put a screen. For magnifying glass is a virtual image, is a screen, right? So if let's say you want to show, let's say I'm trying to show you a virtual image, then the virtual image will be here, right? It will be at the back here like this. I draw a dotted line, okay? So something like that. That will be the virtual image, and then I put my eye here. I have to look. No, as in like there's no screen. There's no screen, bro. Like you look at the virtual image directly. Wow, scary. Lucky your paper 2 didn't come out with this, right? Lucky your paper 2 didn't come out with this. I tell you it's gonna come out with paper 1. Okay? So magnifying glass. Wow. The heck, man? What was that? Hello? Do anyhow drop things around here, leh? I don't want to move, you know. Maybe I have to. Maybe it's a sign. Maybe I'll move to Buona Vista. Huh? No lah, just closer to my own home also. I mean, I stay in Clementi now. Last time I stayed in Queenstown. I can cycle home from here. Then I sold my house and I move out. Yeah. Okay, so magnifying glass is the only application, where what? Where the image is virtual and upright. All other images for the converging lens is always going to be on this side of the lens, on the opposite side of the lens with a screen, and it's always going to be inverted and real. Okay, the size of it depends, right? It can be diminished, it can be same size, it can be projected, right? So it depends on where the how far the object is away from the lens, right? Since it can move the lens and the screen. Okay, now if you don't move the lens and you don't move the candle, right? Let's say you don't move the lens, you don't move the object, right? The image can only be a certain point only. You basically can only move the screen until you see a sharp image, and that's the only position it can be at. Understand? Okay, right. Here's me hoping that ACSi don't actually test a lot of lenses anymore, because legit is not in the IB syllabus anymore. I'm talking about ACSIP, right? Like lenses, right, used to be a very big thing in the previous batch. Like if you have any seniors taking the Jeremy and Glendon, right? Right, like the IB HL physics, right? Not yeah HL physics. They had a extra paper. The extra paper was legit all optics. Like we had to solve questions where we had two lenses. Then you need to do the math for two lenses and draw the diagrams for two lenses. But it's all gone already. They replaced it with relativity, which is an even worse nightmare. I loved it when it was imaging because I can work it out. Relativity, I'm like, what the hell is going on? Yeah, oh my god. Anyway, don't worry. Like I was telling Nathan, I mean, by the time like it's your turn, I should be fine. I'm just struggling with it myself at this time also. Right? I haven't done it in like 20 years, man. Shit, when I was doing it in my university. Okay, not 20, 15 years. Okay. Statements 1 and 2 refers to signals passing through optical fiber of 1.5. Speed of signal is 3 times that is less than Asia must be greater than 41.8. Which of the statements are correct? Okay, not the best question. All right. This question is assuming that the optical fiber has only one layer. That means they only have like one core like that. All right. And the glass is 1.5, and they assume that the outside is like air, for example. Okay. So based on that, we understand that for optical fibers, right, the signal supposed to what? The signal supposed to TIR inside the optical fiber like this, right? Which means that you can use this, go and find the critical angle. Critical angle will be 41.8 degrees, right? If you go and do the n equals to 1 over sine c, right? So I'm going through this because I recognize that this thing here is not a very legit question. I know what the teacher is trying to do. He's trying to water it down because for O level sake, they don't understand two materials. But for ACSI, you need to know the two materials. So I'll go and do that in a while. Okay, I'm going to do that in a while. So this is critical angle 41.8, right? Check, right? Speed of signal is less than 3 times 10 to the power of 8. That is correct, right? Angle of incidence in the signal must be greater than 41.8. That is also correct. So actually both statements 1 and 2 for TIR to occur. Okay? All right, so for TIR to occur, statements 1 and 2, right? The light ray must be inside the optic fiber trying to go out to air, right? Trying to, but it can't, so it will TIR within the optic fiber. So statements 1 and 2. For ACSI, you need to know the two boundary refractive index, and you need to know the critical angle between the two boundaries. I went through that right before paper 2. So I'm going to do it one more time, but this time around I'll leave it to you to figure it out for the next 1 minute, right? Optical fiber, right? You got the core and the cladding material, right? This is the core and this is the cladding, right? Core is, let's say, n equals to 1.5, and cladding, let's say 1.7, right? 1.7, right? Then I'm gonna ask you this: what is the right? So the light ray is supposed to TIR within the boundary. All right. So you need to use your appropriate equation. Can you tell me what's the equation you need to use? core cladding boundary. Can you read out the equation to me, please? Very good. N1 sine theta 1 equals N2 sine theta 2. N1 sine theta 1 equals to N2 sine theta 2. ACSi, please pay attention to this because, right, this is very likely to come out. Some students have this wrong idea that is N equals to 1 over sine C, right? This is only true if the other medium is air. So between the fiber and air, you can use this equation, N equals to 1 over sine C, that's fine. But if it's two different mediums, right, core and cladding, you have to use this. Now, this comes out in the new IB syllabus, so this is a thing that you need to be familiar with. Okay, so Snell's law, this is called Snell's law. Snell's law. Right, so you have to decide where's the critical angle at, right, and which refractive index does it belong to. Oh, did I make a mistake? Yes, I did make a mistake. Did I make a mistake? I made a mistake. What's the mistake? Refractive index of the core should be higher, right? So it should be the other way around. Sorry about that. Right, so this has to be 1.7 and this 1.5, right? Yeah, thanks for pointing it out, right? So yeah, please be vigilant. Vigilant. Your vigilance will bring you very far. Hey man, he's not gonna be there to point out things to you. You have to be. What's with that smelling salts thing? What's that? Is it somehow of like ointment, or is it just for you to smell one? I thought it's like the ointment that you can put. Oh, it's not. It's just a smell thing. Okay, I didn't know that. I got a friend who likes the menthol sticks. You know the white color sticks that they put up in his nose. Damn funny. Like in army lah. Like he always has one in his nose. Then is damn funny. There was once right we camo everything already. You know, like green, black, brown, all the camo all put on already. Then the fella, his urge right, no, his urge are very strong one. Then you take and put. Then the sergeant scold him. Say, hey, I can see you from afar. No, you got one white stick sticking out your nose. Like that. Huh? No, as in like it's just. I mean, it's just like his cigarette law, I guess. Yeah, you know, it's his addiction. He needs to smell it on. Yeah. If not, he will have jitters and shivers. Withdrawal symptoms. Hey, wait. What's the answer for this one, man? Yeah, I'll give you a side question. What's this? What? 61.9, right? So 61.9 degrees. Right, so yeah, I believe that's the correct answer. We good? Right. So the light ray inside here must be greater than 61.9, right? Then you will have TIR happening. Okay? Oh, this is a very interesting question. I have to draw the sequence. Then I mean for me I have to draw the sequence, then I can understand. Right? So I think C's answer, by the way. Right, I think C's answer. So let's do this. So what? What, 25? Oh, the actual answer for 25? No, B 1 and 2 Why? Yeah, what? Speed of light in mediums are always less than speed of light in vacuum. This is speed of light in vacuum one. Right or not? Right? Yeah. So the speed of light in the fiber fiber refractive index 1.5. In fact, how many times is basically this speed divided by 1.5? That's the speed of light. Isn't that the question from paper 2? They were telling me there was a question speed of light in diamond. We had a paper, right? We had a paper that had a diamond in it, right? Didn't we do one of those papers that had a diamond in it? No? What are you talking about? Oh, I created the question. Oh, damn. Okay. I thought we had a paper that had it. Okay. Sorry. One step by step now. So, negative charges, right? So, before I earth it, it looks like this. Okay? Negative charge on this side, then positive charge induced on the left side. Okay? Then you earth it. Then you earth it. What will happen? What will happen, guys? The electrons will, right, will be repelled and then it will escape in the earth, right? So here's the thing, right? So the next step, right? So once the electrons are gone, so I'm doing step by step, so the electrons are now pushed away. So now they are gone, right? So therefore it looks like this for now, right? It looks like this for now. You pay attention to this one step by step, okay? Right? So it looks like this for now, right? Then it says momentarily earth. So now I remove the earth. So it still looks like this for now, right? But without separating, that means you're not physically separating them. They're still in contact. One of them is plus, the other one is neutral now because after you earth it, the electrons have escaped. So this one here generally is quite neutral, right? This one is positively charged because, what? So no, hang on. So they didn't say that I'm like the user is separating it, right? They didn't say that the user is going to separate these two, right? They're left like that. Then they're going to remove this guy. So once you remove this guy, right? You remove this guy. What will happen? So what will happen is that the positive charges will distribute between the two again. I know positive charges don't move, right? What I'm saying is that some of the electrons inside Y will then drift over there, right? So that they can share whatever electrons they have, right? So therefore, it will end up being that both of them are positively charged, and in fact, they will repel each other. Like that. Okay? So the answer is C. Hang on, let me change the question a bit. Okay. Right, so the answer for this question legit is C, right? What happens if I were to say something like this, right? I bring the negatively charged object near, negative charges here, positive charges here, right? I don't earth it, but I just separate the two now. I pull them away. What will be the charges? Then one will be positive, one will be negative. Okay? Or I can earth it now. Let's say I earth it now, right? I earth it, what will happen to Y? Y will become neutral, right? With Z still in place, I separate the two. Then what will happen? Then X will be positive, Y will be neutral. Okay? So the steps the steps do matter. So you have to work it out step by step. Right? For this particular case, right, because I remove the Z, I'm not separating the two, they were still in contact. I remove the Z, the charges will distribute between the two of them, both of them become positively charged, right? So C is your answer. That's for 26. Okay, let's move on. Next one. 27, 28. What's your answer for 27? Oh. Okay, do you draw the circuit or not? Do you draw a circuit or not? Never draw. Very quickly, just draw. Battery and two resistors identical in series. Then the work done. The work done to move the electrical charges through each resistor is 300 joules per minute. Right, 300 joules per minute. Right, what's the EMF for the battery? So 300 joules per minute, I don't like per minute. Let's go with per second. What's per second then? 300 over 60, right? 300 over 60. What's that? That's 5 watts. That means each of these resistors is 5 watts. Right? If you can recognize joules per second is watts, then you recognize that it's 5 watts already. Okay? Then you have a current of 0.5 amperes. Right? So P equals VI. Right? You pretty much, yeah. You can find the V of this one, you add the two V's up. So what do you get? 20. So B is the answer, Okay. How about 28? Hey, what's your answer for 28? What's your answer for 28? C, correct. Okay, EMF, work done per unit charge, right? Yeah, okay. Right, I think key phrase is circuit, the whole circuit, right? Technically speaking, it shouldn't be just a resistor, right? But C is the best answer, right? Because it should be the work done in the circuit for each unit of charge that passes through the entire circuit, not just the resistor, through the entire circuit. But it's okay, there's only one resistor. So if you can, right, just say passes the entire circuit. Right, this is to be a little bit more accurate with your answer. 28 should be C. Right, next one, what's 29? What's that? 29, is it? D, right? Huh? D, alright. Because it's twice the resistance. But the thing is that the second resistor, right, you use twice the correct cross-sectional area. This will actually cause the resistance to be halved. Right? Rho L over A, right? It will be half. So, but you still need twice the resistor, so you need 4 times the length, right? To make up for the difference. Okay, that's 29. 30. Oh, 30 is good question, man. Wow, these people are not playing. Ben, what's the answer for this? Okay, don't give me the answer. Tell me how you will work this out. You have to work it out. You cannot guess one. Tell me how you work it out. Because this is gonna happen tomorrow. This is gonna happen tomorrow. This question is gonna come out tomorrow. Come on, tell me how to work out. What do? You put a voltage. How much you put? No, I always go with 6 or 12, right? I already mentioned before, already 6 or 12, right? Why? Because 6 can be divided by 1, 2, 3, 4, 5, and 6. And you get nice numbers after that, right? 4, maybe not so, because 4 divided by 3, you're not going to get a very nice number. You got like 1.67, right? Right, so it's either 6 or 12. Because 6 or 12, like, you know, when you divide 1, 2 by 1, 2, 3, 4, 5, you always get like a nice round number-ish, right? Or nice decimal and all that. You don't get recurring decimals. Right, so we go with 6 volts. You got to learn this kind of tricks, right? I mean, a bit too late, but yeah, you know, like for you to see the pattern, right? Okay, hang on. when it was like that before you join Z, what's the voltage on X and Y? Yeah, you see, you know this, right? 3 volts, 3 volts. So X has 3 volts, right? Y has 3 volts. Okay? All right, then you connect it. Right? You connect it. Tell me what's the voltage now. Now these two are in parallel. This one here is in series. Don't owe me, tell me. How many volts? Cannot see, then you draw it very quickly on the side like this. Come on, draw it like that. Draw it side by side. Right? That it makes a difference drawing it like this and drawing like that. I mean, if you're a beginner to this, right, or if you're not familiar with this, it makes a difference. Okay, just by drawing it next to it, you see a lot clearer. Then just leave it there. So 6 volts here. How many volts? How many volts, man? What? No, tell me how many volts. You're thinking of 2 ohms, is it? Good, can. So 1 over 2 plus 1 over 2. What do you get? So this one effective resistance 1 ohm. This guy effective resistance still 2. Hey, hello. How much resistance here? 1 ohm. How many resistance here? 2 ohms. Then you split your voltage. Confirm your Sec 2 math damn jialat. Confirm. You must have played them a lot in Sec 2. Can you see it now? How many volts? 2 volts here, 2 volts here, 2 volts here, 4 volts here, correct? Previously, bulb boy was getting how much? 3. Now this is getting? So confirm your answer is A. You understand what I'm saying? Don't use gut feel. This kind of thing can calculate one. So go for it. Right? Brighter than normal. A is the answer. Right? Okay, good. 31, the 30 done. Next one, 31. Aiyo. Oh, these people are nasty, man. Look at that. Yeah, but they shouldn't use 6 volts. 6 volts like that, not fun. Anyway. Just now the question tomorrow will come out, I tell you. Guarantee you tomorrow will come out. Bet. I bet you a cake. Hmm? If you lose, you eat the cake. You feel fatter. Hey, don't be like Mark Che. Mark Che is my year one, no? You know who he is, right? He's my year one. Then all you all know lah. I think you all know him, right? He goes around, right? He's in the APSC, right? Is he? Yeah lah. He's my year one. Last time all the girls all lining up for him, I tell you. Yeah, ACJC, all the girls all lining up for him, man. The tough part is when you stop training and then your appetite still remains. That's when you gain it back. So you gotta learn how to control. Okay. The rest here. As in like, hang on. I mean I got time but it's almost 2 hours already. You got answer for this one? This one you don't know how to do. Okay. So you got stuck and you just skipped, huh? Alright. Okay. So firstly, looks complicated, right? Please spend just 10 seconds drawing it like that. Can? It will help you on. So this guy gets 6 volts. Battery is 12 volts. Yeah, this guy gets 6 volts, this guy gets 6 volts. They both get 6 volts. What they want you to find, they want you to find the resistance, right? Right, so they want you to find what's this resistance, right? Okay, what are you short of now in order to find resistance? You already got voltage already. What else do you need to find resistance? You need current, huh? Okay, so let's do the current, right? Main branch current, 3 amperes, this 3 amperes. Conveniently, they tell you that one of the parallel resistor, the current is 1 ampere. Correct lah. So now you know it's 2 amperes. Alright? So you know already. What's the answer? Yeah. So 3 ohms. Okay? It's very frustrating, right? Because like, you know, something that's simple as this, right? Then you just get lost with all the numbers, right? And all the diagrams and all that. So you got to learn how to simplify it for yourself. Right? That's the skill that I'm trying to teach you all. It's not about physics. This kind of thing in real life, all this kind of the knowledge of this circuit is useless one. Right? I want you to learn how to break it down for people also. Break it down, analyze the problem, because next time when you go to work, it will be this kind of things also. It's not exactly this, but your mindset will be to break it down, redraw it, reframe it, a problem. Then you will learn how to solve it. Okay, 32. What's your answer for 32? Everyone all same? C? Okay, good, should be correct. Yeah. Let's see your answer. Right. 33. 33 is a very quick question, so decide which one. What's that? A, cold thermistor dark LED, right? I don't know, LDR. Sorry, not LED, this is LDR. Yeah, both high resistance, right? Both high resistance means current will be the slowest, so A is answer. Okay? Alright, A is answer. 33. Done. Let's go. 34. Oh, 34. Hot plate 1005, oven 2000. 1 day, hot plate switch on for 1 hour. Oven switch on for 3 hours. Cost of electricity is 30 cents per kWh. What's the cost of using the... Huh? Also, the cooker comes with two parts. One hot plate and one oven. Okay. Like 1 day, they say 1 day, right? 1 day, but then 1 day, right? The hot plate is only used for 1 hour and the oven is used for 3 hours. So, yeah. So what do you find first? You find total. We haven't done this in a while, yeah? Total kWh is going to come out tomorrow. Right? So total kWh, right, is going to be 1.5 times 1 hour plus 2 times 3 hours, right? So that's the total kilowatt hours that you're using. Sorry, what's the answer for this? 7.5 kWh, right? Kilowatt hour, right? Don't forget, this is not kilowatt per hour. This is kilowatt times hour, 1 hour. 1 kilowatt times 1 hour, right? So this is actually a unit of energy. So if let's say, right, I can ask you this also, can you convert this into joules? So no divide. So kilowatt times hour, that will convert to joules, but you must multiply it in seconds. So 7.5 kilowatt hour means 7,500. 7,500 joules per second. Right? 7,500 times 60 minutes times 60 seconds. Okay? Then you get your total kilowatt hour. Can? Oh no, wait, total in joules. Okay, hey, hang on. I don't know whether you remember me doing this. I did this quite a while back. So side quest on something, right? Give you a small side quest here. Right. Some power banks have this rating, 10,000 milliamp hour. This one didn't come out yet, right? Tomorrow gonna come out. Right, 10,000 milliamp hour. Okay? So when you convert this, what do you get? So this is your power bank. Your power bank has a label that says it's 10,000 milliamp hour. So I draw the USB-C ports. Right. What's the brand? What's the usual brand for power banks? What's it? Anchor. Anchor. Right. 10,000 milliamp hour means what? What's yours? What does yours say? 20,000 milliamp hour. Wow. Heavy, yeah, that one. Yeah. Heavy. You want what? 10,000 only, you want? 10,000, yeah. 10,000. Okay, but what does this convert to? Yeah, what does this convert to? Okay, so milliamp hour means what? Means is milliamps times hour. Alright, what is ampere? Ampere is current, right? Ampere means current. So what happens when you take current and you multiply it to time? What do you get? So you got to think about current. What's another units for current? Very good, coulombs per second, right? Ampere is coulombs per second, right? Because I goes to Q over T, okay? I goes to Q over T. But please remember that I is a base unit. Current is a base unit, not charge, right? If let's say they ask you, can you express charge as in base units, right? If let's say they ask you Q in base units, Q in base units, right? That means Q equals IT, which means that the units is ampere second. S, right? Ampere second, right? A dot S, A times S, okay? So Q is not a base unit, right? Current is. Okay, but anyway, so what happens when you take ampere and you times hour? What do you get? You will get coulombs. You will get coulombs. Basically, your power bank is storing charge, right? So when you try to charge your phone, you're basically unleashing charge into your phone. You charge your phone. You're filling your phone up with charge, with coulombs, with electrons. Right? There's a study by some university where they try to measure the mass of electrons using a power bank. So when you fully charge a power bank, right, it's just ever so slightly more massive than an empty power bank because it's really full of electrons. It's crazy, right? There's a lot of electrons, right? But the mass difference is like super small, in the micro nanograms. Okay, super small. Okay, or even smaller than that. Actually, I might be wrong. Anyway, so 10,000 milliamperes, like legit, is 10 ampere hour. Can? And this is equals to 10 coulomb per second times 1 hour. Yeah, which means that it's 10 times 60 times 60, which means it is 36,000 coulombs of charge. Right? That means your 10,000 milliamp hour power bank can provide you with 36,000 coulombs of charge. Okay? Tomorrow come out. Okay. No, but what if they ask you to show this in base units? Okay? Then it just becomes 36,000, because we know coulombs is just coulombs, units of coulombs is just A times S, right? Then you just put A dot S. That's all, right? Ampere second. That's it, right? This is the base units, ampere and seconds. Okay, so just in case they pull a fast one on you, be sharp, be fast, be vigilant, be meticulous. Okay, that's for 34. We're almost done already. Right, 5 more questions go, 6 more questions go. Come on. Before I have to deal with the year 6 IB. Who are here already, I think. Who's this girl outside? Don't know. Feeling fat, don't go eat that. Yeah. Just protein. Yeah, just do more protein. Do less. Just go and buy Tori Q next time lah, right? Just buy the protein. You know? Don't go and buy the soda and all that. Soda will kill you, man, I tell you. Huh? Also still got calories, right? It's zero sugar, but it's got calories, right? Isn't it? No, but sweeteners also got calories. Really, man? Okay lah. Negligible lah. Then you go and ask Mark Chia and Joseph Schooling. People concerned about you lah, your health. No lah, I'm just saying you. You slack only afterwards you gain weight already. Okay, what's the maximum number of lamps that be connected without blowing the fuse? Kaboom. 20 lamps will blow, right? 20 lamps, so 19 is the answer. Okay, so 20 lamps will be just nice 10 amperes because all these are in parallel, so each of them will draw 0.5 amperes, right? So if you go all the way to 20 amperes, you just nice draw 10 amperes in the main circuit here, you're going to blow the fuse, right? So you have to do 19. So C is your answer. So the hit fuse rating improves. Yes, that's right. Hitting the fuse rating makes it blow. That's right. Number 36. 36. 36. Position M. Right? What's the... Yo, that is so weird. What? What? No lah. No lah. This one here cannot lah. No. At least this question is not legit. This question cannot. There's 2 answers for this one at least. It's either C or D. Okay? It's either C or D. No lah. No. You cannot. Wait ah. Oh no, yeah, right, Isaac, yeah, right. Yeah. This answer. Because as it continues turning, it'll reach a maximum, right? So the next action of it is becoming maximum, which basically is maximum. I thought it's about the negative and positive. It's not. It's about what's gonna happen next. What's gonna happen next for this guy is as it continues to turn, right? That means it's already gone past the maximum, it's gonna become 0. Right? So by the time it hit vertical, it becomes 0, right? So C wouldn't be the answer. D is your answer here. Woo! Thanks. Yeah, so this is the answer. Oh, good question though. This is a novel question, not seen this before. Yeah, like yeah, that's a good one. Yeah, that's a good one. This teacher is really legit. Maybe that's why I don't get a lot of CHIJ every year. Wait, actually I do what? Oh, Senix, sorry. I get the CHIJ Senix. This is CHIJ Toa Payoh. Senix. No what? Just do this one lah. Do this wire. Yeah lah, correct right? Do the wire, correct right? Right. So what's your answer? D. Anti-clockwise and Fleming's right hand rule. Right hand rule, correct. Okay, so this is trying to find the induced current. Good. 37. 3 more questions and we're done. 3 more questions and we're done. All right, what's X, Y, and Z? Ooh, nice one, nice one. There's a source that produces all three radiation like a freaking firework. Hey, if you're... Uh-huh, uh-huh. Yeah, come on. What's the answer for this one? That's a good question. Huh? X is alpha? No, X is alpha. Okay? B is your answer. X is alpha. Right? Y is beta. No, Z is beta. Sorry, Z is beta. Y is gamma. All right? But why B? Tell me why. Tell me why. That is correct. What is it? What's less inertia? Which one? Beta particle less inertia. A bit weird, but you're using inertia. Typically, I wouldn't use inertia, but straight away just say less mass. Right? Beta particles are electrons, so they are very light. Alpha particles are 4-2 helium nucleus, 2 protons, 2 neutrons, so they're massive. Right? One proton alone is about 2,000 times more massive than an electron. So a helium particle is 8,000 times more massive than an electron. Right? Yeah. Gamma is not deflected. Right? Okay, good. Deep dive one more part here. What's the direction of the magnetic field? Yeah. What's the direction of the magnetic field? What's the direction of the magnetic field? Right, I give you 4 options. Right. This way, this way, this way, or this way. Right. So, which is the direction of the magnetic field? Think carefully. Think carefully. Think carefully. What's the direction of the magnetic field? Think carefully. Think carefully. Use your hand rule properly. No, you have to use from the start here. It goes out like that. So all the particles are all going upwards at first. Yeah. Then how they deflect is the force. Right? I know it deflects down because like immediately where is it deflected to? To the right. Don't keep thinking it's down. In order to go down, it must deflect to the right. It keeps on right like this. If you turn right 3 times, where do you end up? It's a U-turn. Right? You're driving, you turn right 1 time, turn right 1 more time, turn right 3 times. I'm back in. Right? So the deflection of the beta particle is to the right. So you use your left hand rule. It's a negative charge, right? In order for it to have a force to the right side like this, okay, the current must be pointing down because it's a beta particle, and therefore the field must be pointing into the page. Correct? Then how about for X? Right? X is alpha particle, right? X is a 2+ charge, it's positively charged. So you could do the left hand rule like this, right? The force on X is pointing towards the left, right? It's being deflected towards the left side. So you use the left hand rule, right? The field must be pointing into the page. Can? Yeah, good. So that's on. Emma got this question. Let me show you this. Emma from SOTA got this question. This one here. North pole, south pole, alpha particle going into this. Where's the deflection? Oh, this one is good. Where's the deflection for that one? Alpha particle going into north and south pole like that. Where's the deflection? Where's the deflection? That's right. Yeah. What? I mean, that's correct. Yes. Say it. Why are you rotating your hand? You already got it the correct way the first time, right? Huh? Into the page. Yeah, into the page. Yes, into the page. So this alpha particle will deflect into the page. Obviously, I can't draw that, right? It's kind of like it will just go in like that, and then it will just bye-bye. It will go in like this, right? It will just deflect into the page. Okay? You know? Yeah, but that's the weird ass question. I mean, I regret not putting this into my notes. Like, you know, it's just a different perspective. Sometimes like, do I really need to cover all perspectives, right? Gosh, feels like I need to. Okay, I know that I didn't do this. It's been on my mind for the last couple of months. I was like, should I put it inside? And always like other things, right? Okay, 39. Ooh. Huh? Yeah, this one cheap lah. This one. Answer is B lah, right? Wait, got alpha or not? Don't have, right? You use paper, right? You use paper. 630 still 630, right? So no alpha, because if there's alpha, using paper it will have dropped by a lot. So there's no alpha. You use aluminum absorber, means that you're trying to absorb the beta. You can absorb the beta, but the count is still 180, which means it's still higher than the background count, right? So that means there's still gamma. There must be gamma. So B is your answer, beta and gamma, right? You know what? Give me how much beta and how much gamma. How much count is due to beta, right? And how much count is due to gamma? Wait, 180 minus 25. This one is 155. Gamma is 155, right? And then beta is 630 minus 155. Wait. So 630 minus 25, then minus 155. 450. Correct or not? Wait, 630. 630 is everything, right? Background, gamma, and beta, right? So I minus away background first. So 630 minus 25, I get 605. And then I minus away the gamma. Gamma I already calculated as 155. So 605 minus 155, 450. Yeah, so this should be your values here. Can? Right, just be very aware that they can do this kind of questions also. This one here. How about this one? Last one. Then we are off. Isotopes. What kind of stupid question is this? Ayo, same number of protons, different number of neutrons lah. Pong, different number of electrons also. Different, same electrons. My gosh. Okay, so C is your answer. Same, but different. Okay, all the best to your papers tomorrow. All right, Alyssa, please let me know if you have any paper 2 questions. Thanks for staying online for so long, guys. It's like 2 hours now. Right, what? Got any more for practice later? Oh, that's a good question, huh? You go and do your ACS paper lah. Go and do your ACS paper, or you go and do the MGS paper lah. You go and do the MGS IP one, the one that the Aviata sent. Yeah, do the paper that she sent. The one I sent in the WhatsApp chat. This bunch of pictures here. Go, right? Go and do. Yeah, I already saw her make some mistakes already, so you can go and check whether she made mistake or not. Right. So quite a lot of questions there for you to do. Surprisingly good paper to do. That's why I sent it out. Just now I saw the MGS paper. That one was not so good. That one's too easy. That one. Yeah. All right, those online, thank you very much. Bye-bye. See you when I see you. Not sure when I'll see you, if I'll see you, but bye-bye. Take care, guys.